Central banks play a critical role in maintaining economic stability. They manage inflation, set interest rates, and regulate the money supply. Their policies directly influence employment levels, economic growth, and overall stability of the financial markets. As globalization has become ever more prevalent, central banks have become deeply interconnected, with rate decision from one having an effect across the world. This interdependence means that understanding how central bank communications affect the global economy and other banks is critical, and that is exactly what our project, Words That Unite the World, aims to uncover: how central banks around the world communicate policy. Our dataset, the World Central Bank's corpus, is the largest monetary policy dataset there is. It spans across 25 central banks across 6 different continents, covering 1996 to 2024 with over 380,000 sentences, of which 25,000 sentences were manually annotated by a team of trained annotators. We have benchmarked a wide range of pre-trained and large language models and ran over 15,000 fine-tuning and inference experiments. Our analysis focused on 3 tasks. Number 1, monetary policy stance, whether a sentence is hawkish, dovish, neutral, or irrelevant. Number 2, forward-looking communication, whether it is about future policy or describing current or past conditions. Number 3, uncertainty estimation, whether the statement is certain or uncertain. This slide illustrates our end-to-end process for building the World Central Bank's dataset. Let us start from the left-hand side. First, we selected 25 central banks based on net asset size and availability of meeting minutes in English. Once the banks were selected, we scraped their official communications, cleaned and standardized the data, and consolidated into structured JSON files per bank. Now, moving to the right-hand side, which covers the human annotation workflow, we formed 25 annotation teams, one for each central bank. Each team researched their assigned bank and collaboratively developed annotation guides. During the annotation process, annotators independently labeled 500 sentences and conducted disagreement resolution. Finally, an expert reviewer conducted a secondary review for quality control. The result was a clean cross-bank annotated dataset ready for benchmarking and modeling. To evaluate how well models can interpret monetary policy communication, we designed a comprehensive benchmarking framework. In total, we tested 7 pre-trained language models and 9 large language models. For each model, we ran multiple configurations, varying seeds, learning rates, and batch sizes. We evaluated models under 2 distinct setups. Number 1, the general setup, where the model is trained on the combined dataset from all 25 central banks. Number 2, bank-specific setup, where a separate model is trained only on one bank's data at a time. Across all 3 core tasks, a consistent pattern emerges. The general setup models significantly outperform the bank-specific ones. This tells us that the whole is greater than the sum of its parts, that there are shared linguistic and policy patterns across the central banks. This slide captures one of the most important findings of our study, that models trained on all central banks together outperform those trained on any single bank alone. In other words, the whole is greater than the sum of its parts. As we can see from the graph, the performance improves steadily and begins to plateau around an F1 score of 0.74, showing that the model reaches stability once it has seen about 600 sentences per bank. But to understand why the general setup or the whole performs better, we analyzed this from 2 complementary perspectives: qualitative and statistical. Qualitatively, we looked at sentences that were misclassified by bank-specific models but correctly classified by the general model. In these cases, we found out that the general model had learned from semantically similar examples across different banks. Statistically, we measured cross-bank document similarity, and we found a positive, significant correlation between the performance improvement on the semantic similarity. Beyond just benchmarking models, we wanted to understand whether our framework actually captures economically meaningful behavior, not just linguistic patterns. To do this, we used our best-performing stance detection model, Roberta Large, to conduct a large-scale economic analysis across the central banks. we computed a document-level hawkishness score as shown on the screen. We then track this hawkishness score over time and compare it with consumer price inflation in each bank's corresponding region. We observe the consistently hawkishness tracks inflation, demonstrating that our model's linguistic outputs correlate strongly with real-world macroeconomic dynamics. To test whether large language models can not only analyze but also generate realistic monetary policy content, we ran a meeting minutes generation experiment using GPT 4.1. For each central bank, we take its most recent pre-cutoff document as input. We then feed in documents from the other 24 banks released before the same time window, essentially giving GPT 4.1 global policy context up to its cutoff. The model is then asked to generate the target bank's next set of meeting minutes, simulating what it might be written had it attended that post-cutoff meeting. After generation, we compute hawkishness scores for both the generated and the actual post-cutoff documents, using our fine-tuned Roberta large stance model. When we fit a cross-bank linear regression between these two sets of hawkishness scores, we find a positive and statistically significant correlation. This experiment shows that our framework can be used not just for understanding central bank communication, but also for evaluating and validating model-generated economic content. Beyond our main experiments, we ran several supplementary evaluations to validate robustness and generalization, including human evaluation to compare best-performing LLMs against human annotators, and error analysis to identify where the models struggle the most. For transfer learning, we extended the framework to two new contexts: the Czech National Bank as a 26th unseen central bank and the US Senate Committee on Agriculture, Nutrition, and Forestry hearings, both showing strong cross-domain generalization. Finally, we explored few-shot prompting and few-shot with annotation guides, but even with these strategies, fine-tuned PLMs still outperformed LLMs on average. On the right, all materials are publicly released. The largest monetary policy dataset to date, 78 fine-tuned models, including bank-specific ones and the general setups, a 133-page annotation guide to ensure reproducibility. Altogether, this release supports transparent, open, and globally representative research. To conclude, all our materials are publicly available and fully reproducible. You can scan any of these QR codes to access the project website, code, models, paper, with annotation guides. Together, these resources make the World Central Bank's project not just a dataset, but a foundation for transparent, global, and interdisciplinary research at the intersection of economics, language, and artificial intelligence. Thank you very much.